Hello, everyone. First of all, we would like to welcome our prestigious and the most experienced Safe Practice Head, as well as a transformation partner, Mr. Oskar Kawecki, to this event. Hi, Oscar. Welcome to this webinar.
Thank you. Thank you so much, Max. It's always a great pleasure to host those events with you. So thank you. It's an honor to be here.
Great. Absolutely. We are excited to have you here, Oscar. And before moving on, I would like to talk a little words about what is upgrade knowledge at. Upgrade Knowledge is a workforce upskilling and a transformation partner to enterprises worldwide. We train and we provide certifications to individuals who want to excel in their careers. We are not just a training provider, but we also a transformation partner in your entire journey so that we transform your careers. So just now, we are going to start this session with Mr. Oscar. Oscar, over to you on Safe for Hardware.
Thank you. Thank you so much, Max. Before we will get started, I would just like to also very briefly invite everybody to the upcoming SAFE Summit in Denver, Colorado on September 8th. And as you can see, together with Linda Quick, we will be there at the booth A109. So if you will be there at the Safe Summit, it would be absolutely amazing to meet you and to have a chat with you and to answer every question that you might have considering Agile for hardware and obviously other topics as well. So I hope to see you at the Safe Summit. And very briefly about me. So yeah, thank you, Max, for the introduction. So I'm Oskar and I'm an SPCT, but I'm also a Lean Six Sigma Black Belt. And this topic is really, really important to me as I have a lot of experience not only in building software, but also in cyber physical systems. And I'm more a lean person than agile person. And actually, this is what Dean Leafingwell himself asked me when I was at my SPCT cohort, and he asked me why have I chosen SAFE, and my answer was because it's more lean than agile, and that I can actually apply both of those practices to the to my work. And today I would like to share my experience with you regarding a topic which I think is very, very hot right now on the market. So Agile for hardware, meaning can we actually use and can we scale agility using lean and agile principles to building those big cyber physical systems? That's the $1 million question. Many of you are looking the answer for, and I will do my best to help you to find this and to give you the answer in the next
Fantastic,
upcoming
Oscar.
hour.
That's fantastic, Oscar. So for Agile for software, we have learned a lot. Now this session is more of going to be like Agile for hardware. So that's exciting, Oscar, to learn from you.
Thank you, Max.
So
And this topic is really, really close to my heart. So I'm pretty, maybe I'm even more excited than you and the participants.
that's great.
Okay, so without further ado, let's jump in and dive in into this topic. So, you know, and everybody knows that today's business environment is basically more challenging than ever. And to survive and thrive, every business must act like a tech company, embracing the rapid change and technologies, obviously, like AI. So, quoting the famous quote by the former CEO of JP Morgan's, we are all software companies. In this case, we just happen to have a banking license. In the future, I will say that everybody will be saying that we are all software companies. We just happen to build some hardware as well. And how important it is, look at this issue from this perspective, that the digitalization and the increase of software in physical products creates such a disruption that by 2030, the software will cover more than 50% of cost of a car. So imagine this, that if you will be driving a 20, for example, K car, the 10K will be basically consumed by the software. And obviously, as you might expect in the future, this ratio is going to grow even more. And I know that we have a really, really experienced audience here today. So you probably know the slide, and we for sure cannot predict the future, but at the same time, we can observe the patterns and we can learn on those patterns. And as you can see over here by the work of Calorota Perez, she has found out that every 50 years or so, as you can see, the technological revolutions, they created the new economic order. And you always have three stages. You have the installation period. So this is in most of the cases the domain of the startups, where the new technology or new ways of working comes in and starts creating the disruption. Then you have the turning point, and those companies who pass this turning point, they go to the development period, when the technology or the new way of working becomes a standard. And guess what happens to those companies who don't pass the turning point? Unfortunately for them, they become those relics of the past age, and they are basically gone from the market. And an example that will be, I believe, pretty valid to this group is that at the beginning of the 20th century in Detroit only, there were more than 30 different car manufacturers, including Ford. But, now Ford comes with his mass production line, and this is basically the turning point. Yeah, all the companies who embraced the new ways of working, they thrived in the development period, and guess what? Those companies who did not, you simply do not hear about them anymore. But also, as you can see, it creates basically a new order, working on order in the work, but also the new methods for managing work and the people. So as you can see, if we are now in the age of software and digital, as you might expect, the Taylorism and Fordism and that are pretty outdated. If you look at the sequence, they are no longer valid. Yeah, now we are in the age of software and digital, or are we? We are going to talk about this a little bit more later, because I think that we are already in the age of AI and we are past this age of software and digital. But at this time, as you can see, the lean and agile practices, they are the new methods for managing work and the people. They have become a standard, and they, especially now, because lean is pretty well known. We all know Toyota production system, which is a standard all around the world, but now the agility disrupts the market, as we know, and it also comes to hardware and starts disrupt this niche, and this segment as well, which we are going to talk about in a second. And yes, when the disruption hits, as you can see, even the giants can stumble, and even the bigger car manufacturers like Ford and Volkswagen, they are now in real trouble. And the reason is that they simply cannot adapt fast enough to the ever-changing environment. So they are facing raising costs, they are facing the EV transitions, but in most of the cases they are facing the software-driven disruption, which they are which they are simply not ready for. And their size and legacy structures slows them down and also slows the innovation. But what is the risk for Ford, for Volkswagen, and the other companies in the world? That if they are going to stand still, basically they will lose the market share, and they will start to fade gradually, maybe even more fast than that they could imagine. But at the same time, when disruption happens, as you can see, the key is the speed of innovation. And we have here two examples from SpaceX, obviously, and from Tesla, which are disrupting the market for the last couple of years quite heavily. And just to give you some of the examples, the Tesla, in Tesla, they have the digital twin for every car that they are launching, and basically they have the sensors in each of the components of every car, which analyze the data in real time. So imagine they have millions of cars which are basically riding around the world, and they are analyzing the data from not even each individual vehicle, but each individual component in the vehicle in real time. So imagine how much data they are analyzing every second. And if you think that for your organizations working in 2 week sprints is too fast and you cannot keep up, in Tesla already this data is analyzed by AI that sets the sprint goals for the teams who are working in, wait for it, 3-hour sprints. Yes, not 3-day sprints, but 3-hour sprints, meaning that the AI analyzes the data. Let's say that the customer didn't refused to collect the vehicle because there is a problem with the body. Maybe there is a problem with the paint, and the team, a cross-functional team, is being assembled by the application, and they need to solve this problem in 3 hours and basically implement this change into the production. And at the same time, in SpaceX, there is no front-up final rocket design anymore. There is only the vision. So the rocket needs to, fly to this kind of altitude. It needs to lift this kind of cargo. In most of the cases, it's going to be the satellite, and that's it. And the teams need to organize and find a way how to deliver this new rocket as fast as possible. And in SpaceX, they have mastered 3D printing so well that their engineering teams are now able to design, 3D print, and integrate a component to a physical rocket in 48 hours. Yeah, so imagine that for most of the companies, this process still takes months and even years, and they are already doing this in 48 hours. And this, as you can see, creates the disruption that their competitors simply cannot keep up with anymore. And as you can see, in around 2008, the early agile software innovators like Google, Netflix, Facebook, Amazon, many of them who were startups. Yeah, Jeff Bezos was selling books from his basement. As you can see, they are now basically owning most of the market, following by the agile software early adopters, but as you can see, we are still in the very first phase of this digital transformation, meaning that we are in the innovators and the early adopters first phase. We are not even close to early majority and very, very far from late majority, which shows very clearly that the technology is disrupting the industry very, very rapidly in this early innovative phase. And at the same time, as you can see, the agile hardware innovators around 2015 to 2021, like Amazon, Tesla, but also Apple, as you can see, and Vimeo and Amazon, because they are also investing very heavily. They are the innovators in the agile for hardware delivery. And if the history is going to repeat itself, and we know that the history has a tendency to repeat itself, then those companies in the next 10 or 20 years, they will be the Netflixes, the Amazons, the Apples of the software development in hardware development. So it is a wake-up call for most of the companies now around the world, because if you think that you have time, if you think that you are Mercedes-Benz and you have 100 years of history and etc., and you don't need to compete with Amazon, yes, you do. You do right now. And if you are not going to change, if you are not going to start applying those changes right now, if you are going to wait a couple more years, it's going to be too late, just as it was too late for those companies who didn't apply the agile software development and lost to Amazon, Apple, and other companies back then when the transformation began. Okay, and we also already see that the digital tech isn't just changing the software, and it is reshaping the hardware industries too. And the new technologies allow hardware companies to design and manufacture faster. They also allow us to reduce the cost. For sure, they shorten the design, build, and learning cycles, which I have showed you an example from the SpaceX. And we basically, how do they do this? Using the digital twins and simulations, the digital and rapid prototyping. So this is the 3D printing that I've mentioned, but also digital manufacturing, where in Tesla and in most of the advanced companies right now, you can change the whole production line by simply changing the code. So you can you don't need to make any kind of physical changes in the production line. You can simply do this through changing the code during the night. And this is the future, and this is how it innovates right now. And as yes, of course, we have been talking about the Tesla, we have been talking about SpaceX, but you have also some good examples from GM, and also some good examples from Boeing as well. And I believe that the most important thing that we learn, especially from Tesla, is that most of the companies, they innovate by the car, and not by the model. But why should we wait for the next model and to come, which is going to take sometimes a year or two, or maybe even three? Why couldn't we innovate by car just like Tesla does? So let me give you an example. When the engineer makes an improvement to a component, like for example making it cheaper, lighter, or generate less heat, we don't need to wait 3 years for the next model to come. We simply apply it straight away to the car that is next in the production line. So if you think that it's not possible, it is. Yeah. So we can apply those changes, and we should, because the cost of delay of not applying them is simply too high nowadays. And here you have this diffusion of innovation, and this is basically from Jeffrey Moore's work. Absolutely great author. If you have a chance to read about it, please do so. But it shows very clearly that in order to go to the early majority and the late majority, where the real money basically is, the companies, they need to cross the chasm. And the chasm is to how can we actually move from serving only the innovators and the early adopters, and how can we move to this early majority. Most of the companies in software development, they have already found a way to do this. Most tech giants, they are already there, but most of the other companies, especially the legacy companies, they have not crossed the chasm right now. And if they will not cross the chasm, then they will start losing profit very, very rapidly to those innovators, and this is going to basically kill their businesses in the next 10 or so years. So as you can see, the digital transformation, it's real. It's not just for the startups, and even the legacy organizations like Mercedes-Benz, for example, like GM, they are making bold moves to stay competitive on the market. But before we go to the examples of practical implementation of those new ways of working, we have to make one thing clear. So the digital innovators share a common characteristics, and it shows that they invest in both the processes and infrastructure tooling that enable fast learning, but also they create a learning culture that values organizational learning and growth. And I think that this is something that we have missed and we haven't been articulating the way we should in scaled agile for the past years. That yes, the companies that really benefit from SAFe, they have not only changed the way how they work, so they have not only changed their processes, but they have also changed their culture. So unfortunately, if you are this legacy organization, for example, from financial segment, and if you think that agility is going to help you, implementing SAFe is going to help you by simply working in 2x iterations, applying PI planning, but you will still have this outdated command and control culture, you're not going to change the culture itself, then you are going to fail. You're going to fail with SAFe implementation, and your digital transformation is going to fail as well. I have seen it. Unfortunately, as you can see, I do not have too much hair on my head because I lost most of it during various SAFe implementations in organizations around the world. And I can tell you from experience, I've learned it very, very hard that those organizations who do not change their culture, they do not also succeed in SAFe. And we have to really, really say it out loud to manage expectations as well. Okay, so if we want to thrive in this digital age and the age of hardware, or maybe the age of AI. So as you can see, I said to you that I promised you that I'm going to come back to the work of Carlota Perez. So I don't even know in what kind of age are we anymore. It all blends, as you can see right now, and it all accelerates. Like we know from John P. Cotter that everything is accelerating, and obviously waterfall is outdated. It cannot keep up with the demands being placed on them. Now we see that what Carlota Perez, the trend that she has identified, is also accelerating, because some of the companies have not even passed the turning point in the age of digital. Now we are already in age of AI, and it's going to accelerate, and maybe those kind of changes are going to now happen every 10 years, maybe then every 5 years, etc., etc. So as you can see, it shows clearly that in the future, only the ones who will be able to keep with the pace will survive, and all the others will not. And how can we do this? The first step is quite simple. I'm sure that you have seen it many times. We simply need to organize around the value. So here the key, the message is clear. If we are organized by functional departments, it leads to handoffs and bottlenecks, and it slows our delivery. In this case, we need to organize in the end-to-end delivery, in the agile release trains, which have the end-to-end delivery capabilities. And this is a must-have. And I'm tired of speaking to the organizations who refused to accept that. If you do not have cross-functional agile teams who are able to deliver a new increment of value typically every 2 weeks, then you will not be able to build anything on top of that. This is like the foundation. And if you are scaling, if you do not have the cross-functional agile release trains who are able to deliver a new increment of value, typically every 2 weeks from the end-to-end perspective, then you will not be successful in SAFe. This is like lying down very weak foundations and then being surprised why the whole building is collapsing, why the structure doesn't work as we intended. So in hardware, we also need to act like startups, and we also need to be able to deliver the end-to-end components or the full products if we want to be successful as well. But the other thing that we have to keep in mind is that we need to very clearly map our operational value streams and also the development value streams. So the operational value streams is basically how we are making the money, how our business looks like. And we know that the development value streams they build, they are the steps, the people who are needed in order to build those solutions which enable those steps in the operational value stream. So here you have an example providing an autonomous ride solution, and obviously the ride itself, as you can see, the vehicle itself is a part of a wider and a much larger ecosystem. And the trap that we face is that in most of the cases we are looking at the vehicle itself as the product that is solving the problems for our customers, customers. But if you are looking from the perspectives of jobs to be done, if I'm going to a hardware store, I do not have a need of a drill. I have a need of a quarter-inch hole, if you know what I mean. So I do not have a need of your car, but I have a need to, move with confidence from one place to another. And we have to think about it from the whole customer perspective. When being in the physical vehicle itself is obviously very important, but just a part of the customer journey. And most of the companies are very, very bad in addressing that. And we know that nowadays the usability is more important than the functionality itself. So it needs to be easy, it needs to be user friendly, etc., etc. Okay, so if we have now I organize ourselves around the value, and if we understand our end-to-end customers' needs, which we are satisfying, the next thing that we need to do is we need to start specifying the system. That's pretty obvious. But now we are going to do this very differently, because now we are going to do this incrementally. And here you have a well-known concept in SAFe, which is called, as you can see, the cone of uncertainty. And please give me thumbs up if you think that at the beginning of the project, sprint, initiative, epic, however you call it in your organizations, we know less than we know at the end. Do you agree? If you agree that at the beginning of the project we know less than in the end, give me thumbs up. Okay, perfect. Oh, perfect. I see a lot of thumbs up. Amazing. So if the answer is yes, then please tell me, why are we making all the decisions up front? It doesn't make sense. We haven't delivered anything, we haven't learned anything, but now suddenly we're locking all those decisions up front. And obviously, in SAFe and in Lean, we are doing something very opposite. Yes, I know some of the decisions will have to be locked, the compliance-based decisions, etc., etc., but everything else must be flexible. And we are waiting till the last responsible moment deliberately with making those decisions, because we need to learn and we don't want to make them in the worst possible moment, meaning we don't want to make them upfront. Okay, so now another question that I would like to ask you is that how long basically it takes you before writing a requirement and validating it? And if the answer is months or years, then basically you are just wasting time and locking in the bad assumptions. And as you can see, here we have the classical V model, and it fails nowadays because it locks the unvalidated assumptions and leaves no room to reduce the uncertainty. And it also assumes that the biggest challenge is just writing a perfect specification, where in reality those specifications are filled with unvalidated assumptions, meaning that from the time when we write the requirements till the time when we validate and verify them in operations or in production environment, it is already to learn. That's why we need an incremental and also feedback driven approach, which is very very different one. And also here at the V model, the problem that we are facing is that in software development, in the worst case scenario, even if the time takes even if a long time has passed from requirements to validation, we still can go back to the design and we can simply redesign the system. Yes, we have lost a lot of time and maybe a lot of money, but we can do this. In hardware, it's not only 10 times, 100 times, 1,000 times, sometimes more costly, sometimes it's simply impossible to do so. That's why we need to start operating differently. So the key message here is don't over-specify upfront, and also use ranges and intent to guide the team, leaving the room for flexibility, for feedback, and for the innovation. And modern architecture is not measured by its completeness, but by its ability to adapt and also allow for change. And a couple of weeks ago, I I had the Safe for Architects training, and at the beginning of this Safe for Architects training, we always ask the students what is what is the definition of let's say classical architecture for you. And on the last training, one student nailed it, saying that the classical architecture is something that is very, very hard to change. And obviously, we would like to make it opposite, yeah, and we would like to make it very, 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 very different. Something that allows for change, where change is basically the natural part of the process itself. So instead of locking the requirements up front, the Agile keeps intent stable while letting the details emerge through backlogs and also through the conversations. So here on the left, you see the heavy upfront the composition. When we write system requirements, subsystem requirements, everything is written upfront. But once again, it's just locking bad decisions in most of the cases in the worst possible moment at the beginning of the project itself. And in Lean Agile, we have a totally different approach. We basically capture the solution intent to align, ensure compliance, and also communicate the why. Why are we building it? And also the teams, they define the requirements at the right time, yeah, just before the implementation. We are going to talk about it in just a second. And this is a perfect example of emergent architecture, which I'm going to show you. So here, as you can see, we make the specification activities as a simple part of the Agile work. And why? Because we know that it is a part of the continuous flow. Yeah. And unlike the traditional approaches, a specification isn't just a separate phase. It's integrated, as you can see, into the regular flow of Agile work. So instead of specifying everything up front, we, as you can see, look at what are we going to implement in the next iteration, sprint, however you call it, what we are going to implement in the next PI. And this is our backlog. And we need just enough specification for this backlog to be realized. And it doesn't make any sense to specify more. And the reason behind this is that we obviously want to learn from the previous iteration. So as you can see, we are just building or we are just investing our time in enough specification so as it becomes an enabler for the future activities. Just like we build the architecture one way and we don't want to deploy the whole infrastructure upfront, we just want to deploy enough code, enough architecture, enough infrastructure for the features in the next PI to consume them, and this is it. The same thing we do here. Yeah, we just invest enough time for the specification to enable the future value implementation in the next iteration, in the next PI, etc., leaving the room for making the decisions in the last responsible moment. So the key message here is that we don't reduce the risk by thinking harder, but by learning faster and testing smaller and more often. And we don't communicate with specifications, but we communicate with backlogs, meaning that I communicate what I want to deliver, and this is the communication. And based on that, I need to have a specification that allows me to deliver this with confidence. So as you can see, it is a totally different approach, the only one that works. One thing that I can add over to here. Okay, but now you might say, yeah, Oskar, but there is a lot of variability in the system, and most of the cases why we're investing in the V model is that the variability is simply too high. So first of all, we don't. Companies fight variability when in the other hand they shouldn't, and the reason behind this is that the variability is simply natural. Yeah, and the reason is that developing solutions is uncertain by nature, both technically and also in the market. And the reason behind this is that the innovative systems have never been built before, so there is no guarantee path. So variability isn't either good or bad, it's just a reality, and what really matters is how and when you are going to deal with it. And the only way how to deal with it is by applying the set-based design, not the point-based design, how many companies do. So the point-based design tells us that we are investing in one single option, and we think that it can be applied in the right way for the first time when implementing, which doesn't make sense, yeah, because if we're working in innovative products and we have never delivered this kind of new product, technology, etc. before, how can we invest in single option and point-based design and hope for the best that everything is going to go smoothly? It will not, because it requires learning. That's why we invest in set-based design, where, as you can see, we invest in multiple design options, and we use those milestones as learning points where we are aggressively removing some of those design options, and we are investing in the right one. And here I can give you a very tangible example from Toyota. So when Toyota was working on their hybrid and on their engine to Toyota Prius, before they have chosen the hybrid engine, they had 70 Yes, 70 different engines they have begun with. And obviously by learning, aggressive testing, etc., they were removing some of them through the time. And they came up with the last option, which obviously was the best one, and it was one of the reasons behind Toyota's success. And now you might say, yeah, Oskar, but if they were smarter, then maybe this engine was there on the shelf, and a very skilled engineer could go there and simply pick it up and look how much time and money they would have saved. But you know what? This engine wasn't there on the shelf. The last engine was basically the sum of the learnings from all the previous iterations that they had. So as you can see, it's not a set-based design is not only choosing the best option, it's also choosing learning and also making sure that the last option is going to be based on the learnings from the previous ones. And as you can see, reducing the uncertainty requires experimentation, and that's pretty obvious. And here we can use the classical Wright brothers example, which many people don't know because it's already more than 100 years after their first flight. But they have basically used, as you can see, a series of experiments to arrive at the best design for the lift. So they didn't design the perfect plane on the paper. They didn't specify the plane up front. No, they ran a series of experimentations to find the right decisions, how to generate the lift. And this was the key to their success, which we can also learn from right now. Okay, and there is also another way how we can reduce the risks, and we can do this through experimentation, yes, as we have already talked about, but also working in the iterative learning cycles. And this is another key message here, is that the learning cycle is the most important word. And most of the companies, even though Agile and Scrum, they will soon have 20. It's going to be 25 years in a second from the Agile Manifesto. They still don't get it. They still think that working in 2 weeks sprints and iterations is working in fast development cycles. It is not. It is working in iterative learning cycles, as you can see. So instead of thinking, what are we going to deliver in the next 2 weeks, start asking the question, what is the biggest unknown? What is the biggest risk? What we don't know and we would like to validate, and then think about it using, obviously, we're going to talk about prototypes, virtual environments, mock-ups, etc. How can we actually close this learning gaps. And if the organizations will start thinking about it this way, this is going to be the best way how to reduce the uncertainty by learning faster and by not locking the bad decisions, but by basically eliminating them. And yes, of course, as you can see, learning is continuous. And yeah, we'll talk a little bit about the milestones in a second. But they are there on the solution roadmaps, and they are basically proof points of knowledge creation and not just the delivery itself. And please remember that each milestone must be demonstrable. So if you can't demo it, it is probably not working. This is something that I always tell to the organizations that I work with. And even more importantly, even every milestone requires new knowledge creation, not just the feature delivery. So if we just said that we have delivered something, but we have not learned anything, that it doesn't make any sense, because as you can see, it is a learning process. And yes, obviously, we are evaluating the progress through objective evaluation of working systems. So once again, if this is a PowerPoint presentation, then skip it, because it doesn't bring any value. Doesn't bring any value at all. Okay, so now let's move into more tangible examples. And let's ask the question, are we able to apply those principles that we talked about, especially working in fast learning cycles and, assuming variability and preserving options, also in the hardware environments? And the answer is, of course, yes, we can. And over here, as you can see, that the continuous delivery for hardware, it basically means that we are shifting left with first the digital models, then the prototypes, and then the real world validation. In software, many companies have already mastered the continuous delivery pipeline, and it's well established. And many companies already use both cloud and DevOps. For hardware, continuous delivery pipeline is still evolving. Yeah, so it's in a very, very early stages. Organizations are now investing in as you can see, digital engineering, so integrated models across mechanical, electrical, and also other domains, and simulations, and even augmented reality to validate their designs quickly. And the reason behind this is that we don't want to wait, we cannot wait for the data from the operation environment to validate our delivery. It is already too late. We're going to talk about it in just a second. The data from operation and the environments, it simply validates how accurate the digital models and prototypes really are. And this is the way how we should look at the new ways of delivery if we want to apply the continuous delivery pipeline, which we are going to talk about in a second. And again, here we have a very great example from the Wright brothers. And yes, just like the other companies right now, they have been facing the same uncertainty, because by the time the flight has never been achieved, just like now we are building products that we have never built before. So what they did, they first identified the unknown barriers. So how to create lift, how to enable control, how to generate the propulsion, and those became the learning milestones, as you can see, and their roadmap to the flight. And then you can see they defined the work to gain the knowledge, how to design the experiments. They've designed the experiments, built the prototypes, and also validated the learnings. And at the third step, they incrementally start building the solutions. Started with sketches, as you can see, and ideas, and progressed to models, mock-ups, wind tunnels, kites, and gliders, to finally build the plane itself. So this is something that you might not have heard of, but as you can see, the Wright brothers, over 100 years ago, they were the pioneers of the Lean-Agile delivery in hardware. So you have this example of the virtual prototype and operational environments that they were leveraged. So if your organization is not leveraging them, then think how your organizations are far behind if the Wright brothers were able to do this already 100 years ago. Now, obviously, that's such a that's both a joke and not a joke, yeah, because that's also the reality. But the last thing that we have to also keep in mind is that regarding how much we are going to effort we are going to put into addressing uncertainty and managing risks, we need to understand that not all the milestones are going to look like successes. They will not. But at the same time, the failure doesn't really mean that we didn't succeed. If we have learned something, then even we can obviously turn even the failures into successes. That's why, as you can see in SpaceX, they do not have a term of rocket explosion or anything like that. They use ROOT, meaning that they mean that they use rapid unscheduled disassembly. And why do they use this? Because it is expected to happen. They know that some of the rockets are going to explode very early, but if they have learned from it, if they have gathered the needed telemetry, then everything is fine. But in order to work like that, we once again need to change the company culture into the blameless learning culture, meaning that as long as we have learned something from the delivery, everything is fine. Yeah, the real problems start not when we stop delivering. The real problems for companies start when the organizations and the companies stop learning. So this is a very, very good example how we can learn from SpaceX. Yes, I know many of the things that they are doing are not applicable. For example, in Europe, in Europe, in the European Space Agency, etc., etc. But still, there are a lot of things that they are doing right, and we can and definitely should learn from them and apply this kind of culture of learning first. Okay, so we have specified, and hopefully we have done this incrementally. The next thing that we are going to do, it's time to the design. And yes, we know that in safe planning occurs at multiple levels, but here the most important thing is that most of the organizations do not get how to use roadmaps, and they use them very, very badly. They think that the roadmap is an execution plan, and it is not. Roadmap is a strategic communication tool, something that should guide everybody in the same direction and that could share the information across the company. It's not a fixed contract, something very opposite to it. And the roadmap must evolve as the new information are emerging and as we are learning. So the key message here is if your roadmap is set in stone, it doesn't make sense because it means that if it's not evolving, then you are not learning. And what we have already said, the real trouble becomes start when you stop learning. So roadmap not as a fixed contract, as a strategic communication tool that should be evolving based on the learnings. And yes, we have already seen the milestones, and just for making it clear, in safe we have no problems with milestones. I don't have any problem with milestones as well, but only at one condition: if those are learning moments when we are validating working systems that cut through the entire architecture. If this is just a status report meeting, then I'm sorry, it doesn't have any value at all. It's even misleading because it shows us, for example, the project has been executed, and 90% of the project is already done, and we still have a couple of months ahead of us, and we are on track. I don't know if we are on track, because maybe all the problems are there in the last 10% of the project. So it just builds, builds the false sense of positive feasibility, and it doesn't necessarily mean that we are progressing successfully. So base the milestones on objective evaluation of working systems. This is something that we should take that we should do. And please remember that when we work in agile, then the uncertainty obviously is very high, but the cost of the changes are very low. Yeah, comparing to hardware. In hardware, on the other hand, the uncertainty is very high, but the cost of the change is very high as well. So instead of working in agile cycles, we are working in rapid learning cycles. And this is what I mentioned to you, that at the beginning of the sprint, at the beginning of the iteration, don't think about what you want to deliver, but is the biggest uncertainty that you would like to close, and keep and think about those milestones as the last responsible moment when you must make a decision, and try to build the iterations prior to this milestone based on that, what decisions we will be making at this milestone, and what information do we need to make this decision with confidence, what kind of learning gaps do we need to close, and those are your iteration goals, and this is what you should be pursuing. And by the time when you will face the milestone, yes, sometimes you will not have all the information, but if you will be able to eliminate most of the unpredictability, and then you will be fine, and you will be able to make the best decision at the given time, and in most of the cases it's going to be fine. So think about this very, very differently. But obviously, if we want to work this way, we must integrate early and often. And this is something that is pretty obvious to the software teams, but for the hardware and legacy systems, it's very, very hard. Yeah, and let's be honest, most of the companies cannot do this yet. Still, we need to, because once again, we're going to talk about systems thinking a little bit later, but objective evaluation of working systems means that there is no value in demoing individual components. The integration points only will tell you the truth and the true status of your product. So if you are not integrating early and often, once again, you are much more in the zone of positive feasibility. And as you can see over here, we obviously start with the experiments and with the prototypes. That's pretty obvious. And don't get me wrong, they are valuable for sure. But we also have to remember that the real value, it comes basically from integrating all those components into larger systems context. And that's why the goal is to pull those pieces together into an integrated test. Yeah, and only then do we get the larger system context needed for meaningful feedback and for the learning. So yes, I know rapid experiments, rapid prototyping is very, very important, but do not forget about pulling those pieces together and to have an integrated set, because only this one is going to give you the right feedback. And how are we going to do this? Yes, we are going to do this by integrating and communicating through modularity and interfaces, as you might expect. Yeah. So the clear interfaces, they make incremental cross-domain development possible and also faster. So here we have an example when we have a camera, and as you can see, we have two teams. One team is working on the vehicle body, and the other team is working on vehicle control itself. But if we're going to use standard interfaces, so if the physical mount is going to have a standard, not and as you can see here, it is weld, and we shouldn't weld the camera to the physical mount, because it will say that, okay, how easy is going to be to change it? Not so easy. So we should have a plug that is going to be universal. And now there are those kind of for all the cameras. There is obviously a standard, and you are using a standard interface HDMI for the vehicle control. And in this case, I can, replace the camera all the time. If I look at the non-functional requirements, meaning that obviously the physical mount is going to tell you that it must weigh, let's say, under 5 kilograms, and the vehicle control is going to say to you, yeah, it needs to have the HDMI, it needs to have those kind of etc., etc. So we will be fine. And as you can see, both the teams working on vehicle body and vehicle control, they can innovate separately without having those dependencies with one another, knowing that the camera itself can change very fast. And please remember that the interface means that your components, they should work with or without the additional hardware, just like the software features, they need to obviously work alone and obviously as a set of features as well. So the analogy is Amazon's API, yeah, and this is the one of the most important and the biggest factor behind Amazon's success is that all the vendors must confirm to those published contracts. So the Amazon tells you that, hey, this is our API and you need to integrate with us to do business with us, and we don't care how your industry, how your software, how your engine, etc., looks like. If you want to do business with us, you need to integrate with us. So this is communicating via interfaces, and we should leverage the same communication, obviously, for our hardware teams. So here you have a more tangible examples. So when the team communicates through interfaces rather than waiting for the full integration. And as you can see, the camera team, they can change, for example, the electrical design and also the mechanical closure without breaking the rest of the system by agreeing on the interface contract. Yeah. So both sides can integrate in parallel with confidence. And this is something that we are aiming for and what we are trying to get. But also, as you might imagine, yes, so here you have the classical safe PI example, or the iteration examples. We must avoid teams learning in isolation. Yeah, so the system itself must evolve through integration points that cut through the architectural culture. And as you can see, we have cadence-based learning cycles. So once again, those are not delivery cycles; those are learning cycles. And in most of the cases, as you can see, there are milestones inside it when we will be making the decisions based on the learnings from those iterations in between. So please remember that the true learning comes from the system evolving, not just its individual pieces, as you might guess and as you might expect. And we want to cut and slice through the architecture. Just to give you a couple of tangible examples. So if I have a printer at the first, let's say, at the first PI, I want to be able to print a test page by simply pressing a button on the physical device itself. Perfect. In the second PI, I want to be able to print any kind of page, but obviously from a computer and the printer connected to it via a cable. Perfect. And the third iteration, I want to now be able to print any kind of page, but using our app. And somewhere there at the very end, when the level of ink gets a little bit too low, then I got a push and communicate that tells me that the level is too low, maybe even redirecting me to the site where I can buy this ink and have it delivered to me tomorrow. So this is, as you can see, evaluating through working systems and slicing through the architecture. Because if I cannot print the test page at the first iteration by simply pressing a button, I shouldn't move forward. It doesn't make any sense. But we are going to know about it only when you are going to work like that. Okay, now you might say, Oscar, it's really great. Sounds like a fairy tale, but please tell me, what about compliance? Yes, the $1 million question. So, and the next thing that we will have to do, we for sure will need to continually address the compliance concerns. And let's start here with the key message. Traditional quality management system is way outdated. It is slow. It slows the learning and definitely doesn't guarantee the quality. Because here, quoting Edward Deming, so the father of Lean and Six Sigma, the inspection is already too late because an inspection, it doesn't guarantee the quality, nor does it improve the quality. Why? Because the quality, either good or bad, is already there in the system, and you cannot inspect the quality in. The only way how to do this, obviously, is to build the quality the quality in. And the classical QMS, which are models which, as you can see, they are based on the phase gates, waterfall models. They simply do not keep up with the modern the demands, and they delay the learning, and often don't, as we discussed, improve the quality or reduce risks. No, they put us in the in this zone of false positive feasibility. So as you can see, nowadays, the verification, validation, and compliance, they all must shift left. Yep. And they need to be planned and proven incrementally, not inspected reactively. So the main difference here is that in the classical waterfall style, and this is how most of the companies are working, even in software development, they say, okay, so we are going to deliver something, and at the end, we are going to see if we are compliant. And it doesn't make any sense, because if we will not be compliant, then the quality, in this case bad, will already be there in the product, and we might be even, in most of the cases, have to go back to the design, which in hardware, as we discussed, is not only sometimes 100 or 1,000 times more expensive, it's even not possible in many situations. So instead of that, looking at this reactively, we need to build the compliance in. And this is just like with the specification. Please tell me, what are you planning to deliver in the next iteration? So please, thank you. Thank you, guys. There will be a recording, so if you would like to take a look and also see the full video, we will be sharing it. This topic is much longer, so it will take 1 hour and 30 minutes to finish everything. But we are getting quite close to the end, so don't worry. So just like with the specification, when we are saying, okay, we are looking at what you are going to deliver, and here is the specification that enables you to deliver that that backlog for the next iteration. The same thing we do when we are looking at compliance, meaning, hey, we need to speak with the compliance people, who are not mean people, by the way. They are keeping us out of jail, for example, when we are in finance, working in finance. And we are saying to them, this is your compliance, what we plan to deliver in the next iteration, in the next PI, etc., etc. Please tell me, what do you expect from us to say that we are compliant? Okay, and this is a very small batch. So I can say you need to deliver this and this and this and that. Okay, perfect. So after 2 weeks, we are meeting with them, and if we have, if we are compliant and we have evidence for that, then we are moving forward. If we are not compliant, it's just like with the printer, where we are pressing the test button, but the test page doesn't come out. It doesn't make sense to move further. So here, as you can see, as we are building the quality in, we are building the compliance in, and we are looking at the compliance at the future, planning with them what we want to deliver and how we are going to prove that we are compliant, rather than looking at this reactively. So a totally different way of working. But if you want to work like this, and if you want to build the compliance in, you will not be able to do this without automating it. It's not enough, and this is going to become your bottleneck in the continuous delivery pipeline straight away. Believe me, I have been there. So instead of as you can see, compliance giving you a set of tests that you or requirements that you are running manually. They must provide you, as you can see, with the scripts which you can automate, and you can run them automatically just like functional tests. Yeah, and they should run continuously in your continuous delivery in your continuous delivery pipeline. And if the compliance is going to stay manual, this is going to be the bottleneck, is going to slow or even break your entire pipeline as well. So as you can see, instead of having the checklist, you need to start running automated scripts in your pipeline in order to build the compliance in. And the last thing, of course, as you can see, we're focusing on shifting left, but I think that this is now already becoming a standard when we're using, for example, virtual or factory environments to validate early, just like the Tesla does, and the Tesla can homologate, so in this case, certify many aspects of their cars in the factory and also in the virtual environments long before they reach the customers. So this is basically the future of building the compliance and also building the quality into our products. So yes, now we are going to talk in more detail about the continuous delivery pipeline. We know that the CI/CD works in software, but once again, can we apply it in hardware? Yes, we can. We have already talked about it. But first, before we start even thinking about it, we need to apply systems thinking. So systems thinking is based on the work of Dr. Eliyahu Goldratt. So he is the famous economist from the 80s who said these famous words that the chain is only as strong as its weakest link. And yes, as you can see, the attributes of systems thinking, which he defined already in the 80s, say that optimizing a component does not optimize the system, and that the system cannot evolve faster than its slowest integration point. And this is the reason why most of the software companies, or maybe most of the companies who are relying on software, saying that R&D and their software teams, they are this black hole, and they are just throwing money in, and very rarely something comes out of there. But the reason behind this is that they are throwing the money blindly. They have not mapped their value streams, and they don't know where their biggest bottlenecks are, and they are not addressing them. So Dr. Eliyahu Goldratt already said many years ago that every company, every organization operates in a value stream, and every value stream has one and only one biggest and most significant constraint. You can also say a biggest bottleneck. And every improvement made to the system, to this value stream outside of this bottleneck, is basically an illusion. And this is the reason why most of the companies are struggling, where the others are thriving. The organizations who are thriving, they have mapped their value streams, they have mapped their bottlenecks, and they are improving very those components which are the slowest. The other companies who are struggling, they have not done this. They are throwing money blindly, just hoping for the best. And when they are having some kind of improvements, it's more basically the reason of luck, not any kind of systematic approach. But as you can see, the solution that we are building is a system, but the enterprise or the agile release train, the team, etc., that builds the solution is a system as well. So another thing that we have to think about is that obviously the factory is a product as well. It is a system that must continuously evolve, and it's even more important that the product that you are building. And this is one of the reasons why many organizations are now failing, because they are focusing too much on their products. But please tell me how much the organizations are investing in you, in agile release trains, in improving their ways of working, in improving the teams, meaning improving the system that builds their solutions. Not so much. And obviously the companies like Tesla, they do something opposite. Yeah, they invest more in the people, they invest more in the factory that builds the product, in the system that builds the product itself, than they invest in developing the products in the very first place. So you need to apply systems thinking in order to be successful. And whenever I start talking to every organization in the world who asks for my help, they always say the first thing that they would like to improve, they would like to improve the time to market. Yes, who doesn't? Everybody wants to improve time to market right now. But what I say to them, and as you can see, we have the classical process of from the ideation to the verification and validation, when, as you can see, modeling and simulation maybe takes 3 days, but it takes 1 week before we go to the integration testing. Maybe it takes 1 day, but then we need to wait 4 weeks for the fabrication, etc., etc. So as you can see, the cycle times means that the work time, the time that actually adds the value to the system, takes 13 days, but it is delivered in 5 months with the lead time of 5 to 0.5 months from the ideation to the validation and verification. And this doesn't make sense. So here we are once again applying the systems thinking, and instead of improving, as you can see, the components and meaning the steps of the system, focus on those delays, yeah, and try to remove those delays from the system. So I really like one quote from Elon Musk, who said, as easy as it might sound, yeah, and as obvious as it might sound, the best system is no system. The best step is no step. The best part is no part. Why? Because if you are going to apply them, they are going to apply those delays between those steps, and they are going to slow you down. So we are not going to get to production faster by coding faster or by simulating faster. We are going to go to the production and to the market with our products faster, but by eliminating those non-value added delays and those ways in the system. So if your organizations want to go to the market faster, focus on those delays first, and this is going to have a significant impact. So the last thing, if you want to apply the CDP, as you can see, into your hardware development, you must think of it like a system. Yeah, that's pretty obvious, like a machine, and you must build the machine that builds the machine itself. And from my perspective, investing in the continuous delivery pipeline is far more important than investing in your product itself. And the reason behind this is that we are playing a long game here, and if the system is going to evolve, it's going to be keep delivering better and better products. Yeah, and if we have a really good product, but we are not investing in the system will in short time not be able to deliver this product in a good way, and definitely it's not going to able to evolve this product in the future. So as you can see, the machine that builds the machine is far more important than the products that we are shipping to our clients. And obviously, if we want to work like this, here you have some examples of the technologies that enable the faster learning cycles. And you see the CDP example for hardware in practice, where we don't want to wait until the nozzle is tested in the operational environments to find the defects. That's obviously far too late. So we start with the digital environment, rapid prototyping, manufacturing, and finally the operational environment. But one thing that is key here is that this system works only when you're catching the defects in the environment, and they couldn't be caught in the previous environments. So if you are, for example, looking at in operation environment that your rocket has not exploded, gone through the rapid unscheduled disassembly, but through a defect that should be discovered in the digital environment, it shows a pretty it shows straight away that your CDP is not working. Yes, if the rocket is going through route in the operational environment, is only because we couldn't have caught this defect in the previous environments, and we have learned something. If not, then this doesn't work. And as you can see here, we invest in all levels to ensure the faster learning cycles. So we are individually working on and validating the component level of the nozzle, but even in the digital environment, we try to integrate with the rocket and engine and with the rocket itself, so the subsystem, as you can see, and the system level itself. And this is what I've told you about working in smaller batches and integrating fast and often on every environment, because this only gives us the full knowledge and the full state of the system. And obviously, the last thing we need to do, we need to accelerate the learning. We need telemetry built into the system from the very start, the one that gathers the data from every environment. And we need to have the tools to analyze it. But nowadays, with AI, it becomes more and more simpler as we go. Okay, so being mindful of the time, the next thing that I'm going to go through very briefly is many organizations will now tell me, including you, yes, Oscar, but this is not going to work, and the reason behind this is that we have so many suppliers, we have so many vendors, and how they are going to work with us. This is not going to happen. And the answer is pretty obvious, and the answer is quite easy to define. In SAFe, you simply treat your vendors like separate agile release trains, and this is what we are talking about, those integration points and those APIs. Yes, I do not care if you work in waterfall, if you work in agile, if you work in less SAFe, etc. We are working like this. Yeah, we are working, and we're we are defining the work for the next 10 weeks, and we want to verify and validate at the end of the PI, and we want to integrate the entire system. And we don't care how you work, but you need to integrate with us, giving them the API. And if your vendors cannot work with you like that, or if they are going to refuse to work like that with you, then I'm sorry, but they shouldn't be our vendors anymore. And this is something that changes the whole industry from in the past. Most of the organizations made the decisions we will be working with based on who is going to be on the costs, let's be honest, who is going to be the cheapest and provide the biggest value. Now we are thinking about it from a different perspective, and we are choosing the organizations not who are the cheapest, but the organizations which we will be able to work with confidence. Because if we will not and able to integrate, then the whole system is not going to work, and the whole pipeline is definitely going to break down. So do you want to have the cheapest vendor, or do you want to have a working continuous delivery pipeline? This is the question that you should start asking yourself, and obviously inviting, as you can see, everybody to those PI plannings and to those meetings, and they should also be sharing the pipeline with you, including the scripts, the system tests, etc., everything to ensure the flow. So, as you can see, I know that many of the things that we have talked about today seem like science fiction, but the future is already here. It's just not very evenly distributed. So, if you think that working in 2 weeks iterations is too fast for your hardware teams, guess what? In Tesla, they're already working in 3-hour iterations. If you think that a couple of months is fine to design and integrate a component, guess what? In SpaceX, they are already doing this in 48 hours. And this, once again, they are innovators, but when we are looking at the adoption curve, soon it's going to become a standard. And if your organizations are not going to keep up, I'm sorry, but you will be in huge trouble in the next couple of years. Okay, so the last step, we are going to obviously have time for the questions, but I know we have talked about a lot of things, so this was pretty advanced masterclass, but I wanted to be like that. But at the same time, as you might expect, we have barely slided through the surface. So if you would like to learn more, I have a really great announcement that yes, I will be running the upcoming 4 SAFe for hardware classes in those upcoming dates. So I hope that we are going to see each other in the in the next a couple of weeks and in the next couple of months, and we will be able to share the experience together. Okay, thank you so much. So yes, once again, hopefully see you at the Safe Summit, and where we will be able to have a coffee together and discuss those building cyber physical systems in practice. But now we also have time for short Q&A session.
Thank you so much, Oscar. That was most fascinating to see the speed at which, organizations, the innovators are really, really moving, companies like SpaceX and so on. Let us see what our participants have in terms of questions. Robert asks, can you focus less on safe general and on the how to apply the hardware? Example, relocating a data center or building a new global IP network. Would you like to add a few words about this, Oscar?
Yes. Yes, thank you. Thank you, Cristobal. So I can give you one a big example from one of the automotive companies that I was working with. And basically there I've migrated all their legacy ERP systems for all the 19 factories in the world to S4HANA. And this is, I believe, a very good and pretty much the same analogy. And we know 2030 is coming, and 80% of the organizations have not migrated to HANA yet. And the reason behind this is they think that they can specify everything up front, which is simply impossible. So what I did is I obviously assembled the team, and we said, okay, we stripped the whole, all the functionalities to the bare bone, and what are the core functionalities that we need to migrate. And this was basically something that has to be set in stone from the very beginning, and we did just that. And the next thing that we did, we started working in obviously iterations and asking ourselves, okay, what is the next most important functionality? What is etc. that is the most important for our clients? And we thought about it as building a product, and gathering the requirements from our customers and migrating it step by step incrementally, thinking about it that we don't need to migrate it in a way it worked before. We can treat it also as a chance that now we can deliver it even better that we did in the past. So my answer to you, when you are facing those kind of challenges, don't specify upfront, because it will not make any sense. Just choose, for example, a site and think about what is the core that you need to move, what is the timeline that is needed, and then try to think about it as a product and work on this incrementally, gathering the requirements, building just enough specification that is needed, and migrating, in this case, moving, etc., it piece by piece. This is the only way that works. And last thing, once again, I will tell this so that everybody will make it clear. You don't need to migrate 100% as it looks like now. Treat it also as a chance to think about it. What kind of capabilities are there? What is expected from our customers, from our clients? And are we migrating it, or are we actually, doing it better in order to satisfy their needs? So treat it like a product operating model, and you will be fine.
Wow, so many layers there, Oscar. Thank you for explaining that directly from your experience. Just looking at a few more questions here.
Mhm.
Okay, I have one here that is coming, which says, what role do digital technologies like simulation, rapid prototyping, and digital twins play in agile hardware engineering? I'm sure it's not a
Sure.
question that can be answered very quickly.
Yeah,
But
crucial, crucial. Without it, you cannot do this. But once again, but seriously, it's all about working in those fast integrated learning cycles. And as we discussed, those virtual environments allow you to learn much faster. And it's like in Agile. In Agile, we don't expect that everything is going to go to according to the plan. We expect that we are going to fail, but we want to fail fast and we want to fail cheap, and we want to learn on that. So if you are learning in your production environment, that imagine the cost of the change in production environment is sometimes hundreds or even thousands times more costly and time consuming to actually make a change than in the virtual environment. So make the most of the learnings you can in the left side and environments, and keep the rapid unscheduled disassembly only to the times when you actually couldn't do anything about it, but you have still learned from it.
thanks for that, Oscar. Another one here is what metrics or milestones are critical for measuring progress and quality in scaling agile hardware projects?
Thank you. So this is super important. Thinking once again on the capabilities perspective. What does this? How the customer, how the client, how whoever will be operating, and it is going to use our product. So not thinking about it from our perspective, how we are, designing and building it, but how the clients are going to use them. So think about it like a feature. Yeah, if I cannot perform it, then it probably, if I cannot demo it, it probably is not working. So once again, the example from the printer, I want to print the test page, I want to print via cable, I want to, etc., etc. And now you start thinking about the vehicle itself, and you start thinking about how your customer is going to, for example, interact with this kind of product. You have those capabilities, and yes, you need to show those capabilities working during those milestones. If you cannot, then how can you be sure that you are progressing? Maybe or not.
Right. Thank you for that, Oscar. And
Maybe
to
just
our
last thing
participants,
is like with the Wright brothers. Yeah, if they wouldn't be able to
yeah,
generate lift, how they would be able they wouldn't be able to do anything else. Yeah, so think about it from this kind of perspective. What do we need to do in order to fly? And start to break this down into milestones as a learning points. Thank you.